In this video, we're going to use a sign chart, which I will use a number line to create my sign chart for a polynomial inequality, and that will help us solve the inequality. So let's work through this. Let's say, here's an example. Let's say I want to solve this inequality. X plus 1 squared times x minus 3 to the third times x plus 4 is greater than 0. So if I want to solve this inequality, what that means is find the x values, right, because the variable here is x. So figure out which x values that make this statement true. Okay, so since we're finding all x values where all of this multiplies together to be greater than 0, a couple things. It might be useful to label all of this as y. So what we're trying to do is make sure that y is greater than 0. Figure out what x values make all of this greater than 0. And since it's an inequality, there might be an infinite number of x values that make this true, not a finite number. So the way we'll set this up is we'll create a number line chart, a sign chart, representing the x values, and above that we'll keep track of the y values. In other words, down here we'll list x values, and up here we'll list the values of the polynomial, the entire thing that we're going to call y. Okay, so here's what we're going to do. Luckily our polynomial, our y, is already factored, so we're going to treat this number line chart just like we do with graphing polynomial functions. And we did that in a different video. So the way I'm teaching this is we've already familiarized ourselves with these number line charts, these sign charts, so we're going to use them again. So what I need are the zeros of the polynomial here, and since it's factored, it's easy to see that the zeros are -1, +3, and -4. So I'm going to cut my x number line, those are my x values, at those zeros. So -4 is the first one, then -1, then +3. Okay? So those are my zeros, my x values. And in fact, each of those x values, if you were to plug them in to the entire left side to y, like if I plugged -4 in for x to all three of the x's, and then multiplied all of this out, I would get 0. And the same is true if I plugged in -1 or if I plugged in 3. So those three x values give me a y value of 0. Okay, the next thing we need to do is figure out the signs in between each of the zeros. So figure out the y value in between the zeros. A simple thing you could do is simply pick an x value, for example, that's less than -4, any x value, plug it in for x, and see what you get for y. Okay? See if it's positive or negative. But a much easier way is to use the end behavior based on the leading term. So the leading term here, if you multiplied out the entire polynomial on the left, you'll get x squared times x cubed times x. So that's x to the 6th would be our leading term. So our end behavior for x to an even power, both ends, if we were to graph this y function, both ends would go up, meaning that the y values are positive on both ends. Okay? Finally, to get the y values in the middle without plugging numbers in, we can do that using multiplicities. So -4 has a multiplicity of 1. -1 has a multiplicity of 2. And 3 has a multiplicity of 3. Now since negative 4 has a multiplicity of 1, that means these two signs must be different since the multiplicity of 1 is odd. So this has to be a negative. Negative 1 has an even multiplicity, meaning that these two signs have to be the same. So this would have to be a minus. At 3 we have an odd multiplicity, so these two signs have to be different, and they are, minus and plus. So now we've got all of our y values. We know that we're trying to figure out when y is, so when is y greater than 0 is the question. What x values is that? Because we're trying to find the x values. So now we go back and we want to figure out where y is positive, right? So this means y is positive. So y is positive for x values that are less than negative 4. You can see that y is positive, right? And y is positive over here for x values bigger than 3. Y is not positive here. Y is 0. Y is not, let's put an x through that. Y is not positive here. It's negative. It's not positive when it's 0. Y is not positive if it's negative. Y is not positive if it's 0. So y is positive to the left of negative 4 and not including negative 4. And then y is positive to the right of 3 but not including 3. So the answer to the inequality, the solution to the inequality, is negative infinity to negative 4, not including it, union 3 to infinity, not including 3. So that's the solution to the inequality. All the x values in those intervals make this inequality true. Okay? Try it for yourself. Plug in an x value in either of the two shaded regions and see if you get, when you multiply all this together, see if it's greater than 0. And then try something from this region, and see if it's not greater than 0. Okay? Let's do one more example to sort of solidify our understanding of this. Again, we want to solve. And this time we want to solve the inequality 8x cubed is greater than or equal to 2x to the fourth plus 8x squared. So this one's a little different than the last problem. What's really useful here is to have 0 on one side. So we want 0 on one side and factor the other side. That will help us get our zeros and multiplicities to create our number line chart. So what we'll do is we'll subtract, let's see, here's the highest term, 2x to the fourth. So we want to maybe leave it on the right, and we'll subtract the 8x cubed over. So if I do that, I'll get 0 on the left, and on the right, I'll get 2x to the fourth minus 8x cubed plus my 8x squared. So all I did was subtract 8x cubed from both sides. Notice that on the right side I put it in descending order. That way it could help me. That makes it easier to factor. So when I go through factoring this, I can see that all three terms have a 2x squared in common. So I'll pull out the common 2x squared. Leaving behind an x squared minus a 4x plus a 4. Okay? Now I need to factor my trinomial, which I won't run through the process here. You could use things like the AC method or guess and check, trial and error, whatever you want to call it. But basically when you factor it, it turns out to be x minus 2 times x minus 2, which is x minus 2 squared. Okay? So now we're trying to figure out when this guy is less than or equal to 0. So in other words, if I rewrite it, it'd be 2x squared times x minus 2 squared is less than or equal to 0. So we're trying to figure out when is, and we'll call this guy y, less than or equal to 0. Okay? what x values make that happen. So now it's just like the previous example. We set up our number line chart, cut it at the zeros, which are 0 and positive 2. 0 and positive 2 are the zeros. And let's go ahead and list their multiplicities. 0 has a multiplicity of 2. 2 has a multiplicity of 2. And let's go ahead and identify the y values for each of those x values. If I plug in 0 for all of the x's, then this guy, my y, turns into 0. If I plug in 2, my y also turns into 0. Now I need the signs in between the zeros. I need pluses or minuses in between. So I start by looking at my end behavior and my leading term. If I were to multiply out everything here, I'd get 2x squared times x squared. So my leading term is 2x to the 4th. So again, that's x to an even power. So both ends go up like this. So my end behaviors, my end y values are both positive according to the graph of the ends. Then my multiplicities are both even, so that means the signs here have to be the same. So this would have to be a plus. And those would have to be the same, and they are. Now what we're trying to do is figure out when y is less than or equal to 0. So when y is positive, it's not less than or equal to 0. When y equals 0, it is less than or equal to 0. When y is positive, it is not less than or equal to 0. When y equals 0, it is less than or equal. And when y is positive, it's not less than or equal. So the only x values that work are these two. Now, to write that in interval notation is kind of tough because there's no intervals. We literally get those two x values. So the way we write that solution set is just use braces, not a bracket or parentheses, with a list of the numbers 0 and 2 inside. Those two x values are the solution. Okay? And that's how you solve polynomial inequalities using a number line chart.